Hi everyone, my name is Sakru Nadigati and today I'm going to be going over my CARLA project for CSC 5100. In this demo, I am showcasing a real-time time to collision or TTC risk visualization and near-miss logging system inside the CARLA autonomous driving simulator. And the goal is to go beyond just detecting vehicles and instead quantify collision risk in real time, especially for dynamic multi-agent traffic. So what problem does this solve? Most autonomy evaluations focus on perception metrics like detection accuracy, but that doesn't directly tell you how close you are to crashing. So TTC is a classic safety metric that estimates how long until a collision occurs if the current motion continues. This project operationalizes TTC in CARLA so we can study how risk behaves under different conditions. So looking at what we see on our screen here. Here in CARLA, we have a ego vehicle that is driving among multiple NPC vehicles that are controlled by CARLA's traffic manager. And each simulation ticks such that every time we compute the TTC between the ego vehicle, we also do it in relation to all the nearby traffic participants. You can see the density here. This is multi-agent behavior. So this includes everything like merges, lane changes, braking events, and interactions at intersections. Now, what is the core feature here? You can see every surrounding actor has a bounding box that's color-coded based on their TTC risk. So red means critical, so the TTC is less than 2 seconds. Orange means caution, so the TTC is between 2 to 4 seconds. And then green is safe, so the TTC is greater than 4 seconds. And blue indicates that the TTC is effectively infinite, so that assumes that there's no closing trajectory right now. And above each individual actor, we display that label that shows the TTC, distance to contact, and then the closing speed. So it's not just visualization, it's also quantitative in that regard. So whenever something turns red, that's near critical interaction. So we visually try to emphasize the risky actor, and the system would also do things like log the near miss event. So whenever the TTC drops below 2 seconds, that's when that would occur. More importantly, it also filters out false events like when the TTC equals 0, but we are not closing in at all. This would be when two cars are stopped right next to each other, neither is moving. In those scenarios, we would filter out those events. And each logged event would include things like the simulation time and frame, the ego ID and the target actor ID, as well as the contact distance and closing speed, as well as the ego and target speeds, as well as the ego position. So we can see that the simulation is generating both a live safety visualization as well as a structured data set for analysis that you'll be able to see within my paper. And this simulation runs across all weather conditions to match the proposed study. So I run a matrix of conditions. So for example, for different weather settings like clear, wet, and heavy rain, as well as different traffic densities such as 20, 40, and 60 vehicles, I go ahead and repeat that for robustness. So you might have seen this scenario change a few times. So that's just simulating those different conditions where each run lasts exactly 2 minutes of simulation time. So those comparisons are fair across all those conditions. And after the run would finish, the program would automatically generate a full results package, including logs, tables, and plots. So we can talk about those in our paper as well. That's my demo. I hope you guys enjoyed. Thank you.